Your favorite Edo AI engineer. I'm going to be here building this project, which is a music recommender system. So this is similar to how your Spotify application works, but it's going to be building something just like a prototype of that complex algorithm. And so we're going to be turning out the 5 closest song recommended for the particular song that the user is listening to. For in this case, we're having the song Love Affair, and the 5 closest songs to this is She Called Me Baby, which sounds like a romantic song. You have The Little Girl, For All Times, Have a Little Faith, There's Something in the Air. And if maybe I toggle to a different song entirely, like Return to Fantasy, and I click this show recommendation button, you see it's gonna reloop and give me 5 other songs, which in this case you could find This Moonlight Becomes You, Dreaming, Oceans of Fantasy, Winter's Tale, and Mr. Moonlight. So this song, this music recommender system is just gonna be giving you like the 5 closest songs from its kind of database. So for this project, I'm using like a data set of like 5,000 songs, which I could have done more, but because of GPU and RAM optimization, I kind of reduced that to just 5,000 songs. And so for pulling out this album art, I had to like utilize the Spotify developer API, which helps me to interact with Spotify database to pull up the album art for this song. So I'm going to be showing you how to integrate that in the project. So this is just a good project to sort of extend your machine learning capabilities, to give you some idea of how to like deploy machine learning models at the back end and how it's going to appear for like some use case. So yeah, so without wasting further time, let's jump into the coding of the project. I'm downloading the dataset from Kaggle, so I'm going to be sending the link to the dataset in the link under the video. So you're going to be seeing that here on YouTube. So I'm downloading it. It's going to take some 50 seconds, and then yep. So we're going to extract the data, and then we copy this and we'll just put it in the project folder, and then we'll place it in the project folder. So the same folder that has that IPYNB file. Okay, so the next thing, we'll start the coding project. So for those who are not familiar with like Jupyter Notebook, it's kind of like an interactive environment where you get to see your code being deployed in real time. So it helps you to check that you are on track in terms of completing your project, and if maybe there's a portion of your code that is wrong, it helps you to also diagnose that, instead of you running the whole project and then don't exactly knowing exactly where there might be a bug or where there might be an issue. So with step-by-step deployment of different portions of your project, the Jupyter Notebook helps you to see exactly where maybe you might be having some errors and where you also need to make changes. So it's very interactive, and it's one of the tools that beginners in Python programming should utilize in terms of coding. So the very first thing we're going to be doing, we're going to be importing the pandas library. So pip install pandas. So pandas helps you to like work with data frames. Okay, so I have to first choose a Python environment. Let me pick this 3.12. Okay, then so I'm going to be installing pandas. Then okay, so next one, pip install NLTK, which is natural language processing application, or natural language processing library in Python, which is very useful. We're going to be utilizing that in this project for doing stemming and other natural language techniques that are needed for the project. And also I'm going to be importing a system library. So let me import pandas as PD, then import path library, which helps for helping to like direct project certain files and folders to different locations. So it helps me to do that. And then I'm also importing sys library. Then the next thing I'm going to be doing, I'm going to be reading off this imported dataset. So I'm going to be calling the dataset df then. So imported is pd.read csv. Then just going to copy the file location, copy path, okay, then I come here, Ctrl V, okay, then I have to put some quotes. Alright, so this is nice. And to test if I have successfully imported my dataset to this the notebook environment, I'm just going to use df.head. So when I use df.head, it's going to return the first 5 data inside the dataset. So let me go ahead and deploy. Sorry, go ahead and run this. And then you see that I have very fast 5 data. It tells me this artist is ABBA, the song name is He's My Kind of Girl. Then this gives me the link, and then you see the text. Alright, so this shows that I've successfully imported the data set into my Jupyter Notebook environment. So that's a good win. So step, I'm going to be checking to see if there are some missing spots in the data set, to see if maybe there are like there's a missing row, there's a row that doesn't have like complete data, so that I can exclude that from the training of this training of the model of the project, so that I don't have errors and stuff like that. So to do that, I'm just going to be writing this code df.isNull. So isNull helps to check whether there are blank rows within this data set, and how many rows do they have and how many rows in total. So if I run this code line, I see that I have 0 for the artist column, I have 0 for the song column, I have 0 for the link column, I have 0 for the text column. So which means that I don't have any missing data within this data set. So this data set is very complete, and it is very suitable for this project. So next thing, I want to check like what is the sort of shape of this data set. How does this data set looks like? So I'm going to use df.shape. So it's going to give me this. So I'm having 57,650 rows and 4 columns. So this means I have 57,000 rows. So this is kind of too large for this project, because if I'm kind of training the model, it's going to be requiring a whole lot of more time and more computation resources. So to be able to like make this project get deployed faster and get the training faster, I want to reduce this data set from 57,000 to just about 6,000 data rows. So to do that, I'm going to be using this code. So let me run the code. So that will be df code, which is df equals to df dot sample 6,000 from this data, and then I want to also drop this link column. I don't think I need that link column to build the application, so I don't get to be seeing not useful column. I'm going to drop that. Then I'm going to say drop the link, and then since it's a column, it means that the axis is 1, then rows the axis is 0. So then dot reset index drop equals to true, and then I'm gonna run that, and then to check if I have successfully been able to edit this dataset, I'm just gonna check dataset ahead again, and then it should return a refined dataset. So yeah, so I see that I have just the artist, the song, and the text columns only. And if I also want to check the shape so that I can know if I have exactly 6,000 data rows, I'm going to have this, and you see that I have 6,003, which means 3 columns, 6,000 rows. Perfect. So let's say I want to like read out like the very first the text of the very first row entry. We're going to say dx of text is 1. So if I run that, I'm going to have, I want somebody to share new line, share the rest of my life, share my innermost thoughts, know my intimate details, someone who will stand by my side, blah 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 blah. So all about this sounds like a romantic song. Okay, so if you're having a girlfriend or a boyfriend, it's a nice song to send to them. Okay, back to the project. So yeah, so that is for data understanding the data we're working with. And then the next thing that I want to do is I want to do some string editing. I want all the text to like appear like in lowercase. Like I'm no, for example, in this case I have like I want somebody to share the rest of my life with. All these first letters, they all appear as capitals. So I want to ensure that every letter that I'm working with in this project is only going to be lowercase. So this will be the text cleaning / processing. Alright, so to do that, I'm going to be referencing the df dataset, then the text column, equals to data frame text dot stro dot lower dot replace, then arrow okay, w/s. Okay, then then dot replace. So regex equals true. Alright, so if I run df text again equals to 1, df text 1, so I can see that I want I, which was capitalized initially before, is now lower 1. So I want all this to appear as lower cases. That has been taken care of. So the next we're doing right now is tokenization and word stemming. So for those who don't know what tokenization and what stemming, I'm going to give you some little explanation. So tokenization simply means like reducing tokenization means breaking a huge chunk of text into sub-words or words or characters. Take for instance, you want to break I am beautiful, I am a beautiful I am a beautiful boy, for instance. So you want to break it down into I am a beautiful boy. So you want to break it down into smaller bits so that you can easily process it, feed it to a model, do further analysis with it. So tokenization helps to do that, while stemming helps you to reduce words to their base form. So words like beautiful, beautification, beautify, all these all stem from the word beauty. So stemming helps you to bring all these words and convert all of them to beauty. So that is what stemming does. In that way, it helps you to not have redundant replication of words. So all these techniques are all from the NLTK library. So to do this, I'm going to first import. Let me use the code box. I'm going to import the NLTK library, and then the next thing is from nltk.stem.porter, import the porter stemmer. And so the next thing I'm doing is from nltk.tokenize, import word tokenize. Okay, so I'm gonna run this code box, and then everything should be okay. Okay, I'm having some errors. So okay, I think I'm having issues with model execute. Let me try restarting everything. Let me run all. This should fix the issue. Okay, yeah, fine. Alright, so move forward. Then I create an instance of the porter stemmer. Create an instance. Then after that, I create the usefulness of that stemmer, and then I import regular expressions, and then I create a function to tokenize the text. Token text, that's the name of the function, token. Then I'm going to find all the words. So this is a comment, I'm going to use a hash for that. And then find all the words, and then tokens. So what this is doing is that it's helping to find all the regular expressions I'm having. So okay. Then this stem helps to create all those the stem base form of all the words, and then I stem out the stem of W for W in tokens. Alright, so having created the tokens, which is breaking all the words into subwords from the text, the next thing I do is I create the stem of each of the words in that token. So after breaking everything down to tokens, I now find the stem word for each of those tokens. Alright, then return dot join stem. So it's gonna return the whole stem for each of the words. So this helps return the stem form of every word contained in that text that I feed to this token function. So let me deploy this. Okay, I think I have a little error, which is gotten from unmatched. Okay, I have a redundant bracket. Okay, I know that, so I think it should work now. Okay, perfect. So let me try to like deploy this token function. Let me see if it's gonna work. So tokenize this word beautification of a modernized programming country. Okay, modernized programming American country. I just want to use words that I know that we can have a smaller version. Nationality, functional. Okay, I think it's okay. So let me see what's going to print out for me. So if I run the token function, so you're going to see, you're going to break down this beautification to beautify, off, still okay, AA is okay, modernize, it brings it down to modernist, programming brings it to program, America, or it's based on America here, but it brings American, country brings it down to country, nationality, it brings it down to nation, and functional, it brings it to function. You see that it helps to break, after tokenizing the full word, it now brings together all the stem format of each of all these words. Alright, so it means that my token function is working. Alright, so the next thing I want to do, I want to use what we call the TF-ID vectorizer. So after being able to convert these words to token, I need to be able to use a vectorizer which helps to convert all of those sentences into numbers. You know, models, they don't understand words. So because they don't understand words, what we need to give to them is a numerical representation of the words. So that numerical representation of those words is what we get when we utilize the TF-ID vectorizer. So the next portion of the project is TF-ID vectorizer. And then to do that, I have to check that I have my scikit-learn available. So my scikit-learn is what enables me to do that. So I'm going to be running this. It should be a code. Ctrl C. Alright, so it's okay. I already have it already contained, so I'm good to go. So next thing is from scikit-learn. Some scikit-learn dot feature extraction dot text import TF-ID vectorizer. Then also I want to use what we'll call the cosine similarity. So pairwise import cosine similarity. The TF-ID vectorizer and the cosine similarity. Some of you might be asking, why do we need these two functionalities, which is the cosine similarity and the TF-ID vectorizer? So the TF-ID vectorizer, what it does is that it converts these words and sentences into vectors. We need to convert these sentences to vectors. And why do we need to convert this into vectors? We need that so that we can be able to do what we call a cosine similarity. So take for instance, you want to check between, let's say, France and Italy, how maybe close they are to each other. So what you first need to do, you need to vectorize the words. For sentences, you need to vectorize the sentences, and then to check how similar they are, you now use cosine similarity to check the cos of the angle between the two vectors. So this is France represented as one vector, then Italy represented by another vector. So depending on the angle between them, you have an idea of how close they are. So the smaller the angle between the two vectors, the more similar they are. So in this case, you see France and Italy have an angle of close to 0. So the cosine of 0 is 1, which means that they are very similar. And this makes sense because they are countries. And then you look at ball and crocodile, you see that the angle between them is getting close to 90 degrees. And the cos of 90 is about 0. So it tells you that ball and crocodile, they are having close to no similarity at all. So you see that the angle between them is what gives you an idea of how much similar these words and by extension sentences are. So you see that in order to do this, we need to first vectorize all of the words in the sentence, and that is where those two library comes in. And yeah, so this explains why we are using these libraries. And then I'm going to run the code. Okay, so the next thing we do, I want to apply the tokenize function to all the words I have within my text column. So I use this lambda method. This lambda is an approach that helps you to apply a function across all the elements of a list. So this does that, and then it's taking some time because there's a whole lot of text contained within that column. So it's doing that, and then I think it's gonna, when it's done, it's going to like put out a response. And then I think I can be writing another code line as it's doing that. So what I want to do now, I want to create the sentence vector form, or the word embedding. So the word embedding, okay, you can see that if you look at the code, it has completed applying the token function to every element on the text column, which is like the lyrics of the songs. And then I want to create the vectorizing function that helps me to convert the sentences into the vector form so that I can do the cosine similarity. So you can see that what I'm going to be doing is that when I now have like the word embeddings, which is like the vector form for all those sentences, I now compare cosine similarities of the text from different songs. So the songs that have small angles between their vectors are songs that are kind of close to each other. So by looking at the cosine similarity of these various songs, I can now be able to know the songs that have similar semantic meanings. So that is the whole idea of using the cosine similarity and this TF-ID vectorizer. So if you really understand the whole concept of cosine similarity and word embeddings, you already have a good idea of how this project is the whole brain behind this project basically. So if I want to check out the data frame song, I'm going to see that these are the titles of the songs I have. I want to be with you. I think maybe that was a typo error. It should be I want to be with you, hungry for love, danger us, mandolin, the future song, no more chain gang, share, the end. That's like the last 5 songs. Can love stand the test? Okay, all right. So okay, so this is just checking out the songs. And the next thing I want to do right now, I want to create the matrix form. Or I want to call this the matrix, but what I'm doing, I'm kind of like creating that word embedding of sentences. Fit transform df text, and on this, so it creates a matrix of the word embeddings. Then I create the similarity matrix. So this cosine similarity, what it does is that it creates a vector, a kind of vector that houses the similarity between all the various rows of each of the text rows. That means each of the lyrics of each song. It creates a matrix that compares using cosine similarity for that song with every other song in that 6,000 row of lyrics. So let me take a look at if I want to reference the very first song to spin out the cosine similarity value for the very first entry. So it's going to give me these different values. So you see that it's very long. It's very long. And then I think if I want to put out something like 0. Yeah, okay, yeah. So it starts from 0. So you see that with the very first song itself, it has a cosine value of 1, which means that it is very close to itself. In fact, it is perfectly itself. So since it's comparing it to itself, it will have a value of 1. Just like if you are comparing your face to your face, it's going to give you a similarity of 1. For instance, if you are comparing your face to that of somebody else, it will give you a different value. But with your own self, it gives you a perfect score of 1. So if I do similarity for the second, or for 2, which means the third song, because for indexing starts from 0, which is your first item, then 2 means your third item. So you see that you're going to have 1 on the third item, which means that this song is perfectly related to itself, which means that there's a perfect correlation between its lyrics, and you can see that it has very small values compared to all these other lyrics from other columns. So I think if I want to check, like if I can maybe spin out the shape of this, so I can see how it is. Like 6,000 by 6,000. So what this means is that it is having a matrix and each row of that matrix is the vector cosine similarity of that lyrics and every other song in that 6,000 row. So for each of the rows cater for every unique song. So that's why it is 6,000 by 6,000. So for each row, it has the embeddings for every song compared to every other 5,999 songs. And so with this, you can now be able to create a vector for each song from every column in this similar matrix. Okay. All right. So the next thing I want to do now, I want to create the recommender function. So this is the function that is going to be doing the whole work, and it's going to be doing the spinning out of the top 5 recommended songs. So I'm going to create a markdown recommender function. And so yeah, let me create this code box. So from diff-lib import get close matches, then I'm going to say definition, which is the way to create a function, def recommender exact song name. So I'm going to call this a target. A target is the song name. Is that I'm trying to now build the recommender function. So this is where the main job is done, and I'm building 2 functions. One to take in the exact name of the song in case the user puts the exact name, and in case the user does not put an exact name of a song, what happens in that scenario. So that's what the second function, recommend song lookup, does. So the very first function, recommender exact, so when you put in the name of the song, what happens is that we use the strip and lower methods to remove the front space and the back space from the letter strings. So in case there's a space before and after the letters, that strip takes care of that. And okay, let me show what I'm talking about. I guess maybe you have something like this. Let's say into love affair, and then maybe I put a space at the ending. So what happens is that this strip method takes care of this space here, so it breaks everything down to now become something like this, into love affair. And then if maybe I have a capital A here, this dot lower helps to turn this capital back to a small letter a. So that's just like formatting of text. And then the max method, this is a boolean. So what this does is that it checks the target which we just got here from the song name, which the user imputes. It now checks the song column. After taking this df song, which is like the df data frame, it takes the column song and then it converts the elements in each of the rows of this song column into like it strips like the first and the backspace in case there's a space there, and then it also converts it to like lowercase, and then it now checks it against what the user puts in. So if 2 of them match, it means that this match returns as true, and if it doesn't match, it returns as false. And so when it returns as false, the code now replies with song not found. And so in the case where it is a true, what happens is that this marks.idx marks, what it does is that it tells the code to bring out the exact index where you found your first true value. That's what this does. And so then after doing that, it now uses the index value here to get the vector embeddings, and then you now get all the embeddings and the songs of the closest vectors to that exact one that you put in. So in other words, what this happens in return is that from this return, you see that it kind of locates the exact place where you have your first to sixth closest. So this code is more like a return list, and it is kind of sorted because of this sorted function we put in here. And then it sorts out that, and then it now uses this decreasing method so that the higher one comes in first, and then it now takes out only the first six in that list, which is like the highest six. So that gives you like the top songs that had the highest cosine similarity. And so see, we're calling this similar function which we created from the cosine similar method. So we're using that cosine similar method which we instantiated using similar, and then we are now comparing it with the index that we got when we are comparing the target against the data frame song column. So you see that this handles that situation, and in case maybe we didn't put in the exact song name, so to handle that is where this code comes in to handle that situation. And then if I run this code, so I'm going to get September, I'm talking about a song in your eyes, and then this gives me some recommended songs, which includes September, Baby Driver, Bala Baby, Bump, Mirror, and yeah, those are like the top recommendations. So it gives me want to increase it to like 6 songs. I'm gonna put in that, so I'm gonna get 1, 2, 3, 4, 5, 6. So it just keeps continuing giving me the sorted order of songs that we obtained from that cosine similarity matrix. And so yeah, so this is the project running. So the project is running fine. So the next thing I would have to do now would be download that similarity model, which we're going to be deploying at the back end of the server. We continue from where we stopped, and here I'm going to be saving the model. Yep, so this is the model, new name, similarity model, and Pico. I imported the Pico library, which helps me to save the model, and then Pico.dump, that does that. And the next thing I want to dump, I also want to dump the data frame which I created. So I'm going to add a new code, Pico.dump df open, call it df, and then in WB format. Okay, so when I run this, it's going to save that. Okay, Pico not defined, so I need to restart the kernel, and then I need to run all. So I guess it could not import Pico, so I'm gonna do everything over again. So that should fix the problem. So after this stage, the next thing we're gonna be doing, we're gonna be creating the app.py file, which is simply the main application where everything is going to be run from. So this Python Jupyter notebook was just for running the sample code to just test it to see if it runs and if it works. And since it works now, we can go ahead and deploy it in the standard app.py file. So that will be the next stage of this project. So I think we're almost getting there. Yep. So you see that it has done that. So I'm going to delete one of this. Don't delete the one I created before. But delete that one. Yes, move to trash. Then I call this edit name is rename .pkl. And this also rename .pkl. Okay, so the next thing right now is we create the app.py file, and then we import Pickle library. We import the Streamlit library. So like I said before, the Streamlit library is what's going to help to create the front end for the user. And then we're going to be importing this Spotify Python library, which is called Spotify. So this is how we're going to be accessing the database that contains the album arts on Spotify database, and that's going to be helping us with the album art. So Spotify .oat2, we're going to import the Spotify client credentials. So Spotify client credentials, and then import OS. And then for this, I'm going to be creating a .env file. So this .env file is to contain the client ID and the client secret. So typically I don't advise persons to like put their client's ID and client secrets in the main app.py the main app.py script, because in case you want to push it to GitHub, you don't want everybody to see your GitHub or your client's ID. You don't want everybody to see it. So because you don't want everyone to see it, you want to like deploy it from the .env file, which is kind of much more standard. So from .env you import load.env. So then you kind of load it, which is load.env, and then you have the client ID, which I'm going to be showing you how to access. So I'm going to be putting it as os.environ.get client ID, then client ID, and then client's secrets, equals to os.environ.get client secret. Go out and create a Spotify account. to be able to have access to the client secret and the client ID. So you go to Google and then you type Spotify developer account, and then after typing it, the next thing you do, the very first thing that comes up is Spotify for developers, and then you click it, and then you come here, you see documentation, community, and then you come to your top right and you click. You could, if you haven't created an account before, you can go ahead and create an account, and if you have done that, you just come to dashboard, you come to documentation, then you just see under this first dashboard, you see the create app, but I've already created one before, so you have to create an app, and they're just going to ask you for standard questions, more like the name of the application. You could put music recommendation app there, form project, then application description. You could use the same name, or you could use a fancy name like I did, a locally deployed musical recommendation application, and you could just put redirect URIs. You can just put google.com callbacks and stuff like that. Then API use, I think they have different options here. You have to choose between web API, ads API, iOS, Android, depending on what you want to do. But since I just want a local deployment for this for my PC, I just use the web API, then I save, and then you're going to give me access to the client ID and the client secret. So when I click on this, I'm going to see the client secret. So I'm going to copy both this and come to my .env file under client ID, this, and client secret is equals to, so I'm just going to copy exactly what I saw in that place. So I'm going to copy it, then client secret, then I go back to my GitHub, sorry, not my GitHub, my VS Code, and place it there. So this we're good to go, and I save this file, and I go back to my app.py, and then done with this, I can take this out now. So I come back here, and then the next thing I'll be doing, I'll be populating this this file with the necessary information so that we can be able to complete the app.py file. So next thing I do, I initialize the Spotify. I initialize this Spotify API client. So how do I do that? I just simply create the SP equals to Spotify dot Spotify, then under the client credentials manager, then I click sorry, oh, I got that wrong. So first and foremost, I have to create the client credentials variable, client credentials manager variable equals to Spotify client credentials and client ID equals to client ID, then client secrets equals to client secret. Alright, so next thing, I instantiate this client credentials manager by calling it here, so equals to find credentials manager. Okay, and now the function to get the album cover, so to create the function get song album cover URL. So you have your song name, then artist name, then writing the recommend song function, which is just like a recreation of what we did in the Jupyter notebook. So the next thing for us to do right now is for us to write out the code for the Streamlit body part. So st.header so I'm gonna call this music recommendation system. Okay, let's put smart. I think that's a little bit cooler. Smart music recommendation system. Then I'm calling the model will kind of the df.pkl file, which is like the data set, which I packaged as pkl artifact. And then next thing I do, I'm going to call the similarity model, which I built from the cosine similarity function. So pickle the load, open similarity. I named it similarity model.pkl. Okay, that'll be alright. Now close my braces. And then next thing I do, I call out the music list. Music list equals to music song dot values. Then selected movie. Just streamlit.select box. Select box. And I can just put something there that would cannot be highlighted. Type or select the song from the drop down. Then call in the music list there. Alright. So that's done, and then I now create sort of function for like a button function. So it's gonna be a button function. Then you're gonna hit show the recommendation. So let me just show the recommended songs. Show the top recommended song. Alright. Then I'm gonna pass this. And then the next thing is I'm gonna call out the recommended music names and recommended music posters using recommend song, and then passing selected movie. Okay. Then I'm gonna create about 5 columns because I'm going to be having 5 recommended songs. So I'm gonna stream with columns. I define it with 5. So column 1, column 2, column 3, column 4. Then I call with column 1. So I'm gonna be calling the first recommended song from the function, and then the recommended music posters I'm going to get it from Spotify, and then I'm going to do this again. The recommended for column 2, which is for the second recommended song. I'm going to do the same thing for the remaining 4 of them. So just copy and paste to save time. So Ctrl V, okay, let's change this to 2, change this to 1, change this to 1, change this to 3, change this to 2, change this to 3, change this to 4, and then just change this to 4 and 5. Alright. Okay, so I think this is the ending of the project. Okay. I think I'm going to do some alignment, some little alignment, and we'll be good. Alright. Okay, so we have successfully run the app.py file. Everything looks good. And then the next thing we do is to come over here and then check that our client ID and secret is actually working fine. And then we go ahead and then we go ahead and run this terminal. I'm going to be showing you also how to push this to GitHub code. So sorry, to GitHub repo in case you want to do that. Then next thing is open in terminal. Then next clicking ensure I've saved this code again. Okay, so be able to run this application, you just have to put streamlit run and the name of the file app.py, and then you click your enter and you run. Okay, you can see that it's as created by default. It's using localhost at port 8501. Okay, so I'm having some issue. Okay, it got an unexpected keyword argument client. Okay, okay. Alright, so client circuit, I kind of misspelled it here. So client circuit, I guess I was typing so fast. So, alright. So just one of those blocks you get when you're like running code, so it actually happens a lot. So I'm gonna stop the app and then I'm gonna run it again. Streamlit run app.py. This should do the fix. 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 Okay, smart media system. Alright, okay. So have you ever? So let me see. Show the top recommended songs. Okay, here we go. So you see, it's not just bringing out the names, it's also bringing out the album arts using the Spotify API. So this is a good job. Let's try another song. I had a dream about you. So let me show the top recommended songs. Oh, bringing out Baby, Baby Let's Play, Heavy Whispers, Secret Love. So the name have dream about sound like a romantic song, and the song that I recommend is sound romantic. Let me look at another one, Up in Heaven. It sounds like a spiritual song. Let me look at the recommendations we're gonna give. Building My Body, okay. Building the Bridge, okay. Sounds cool. Yeah, the bridge between heaven and earth, then we're building the bridge between the two of them. Sounds great. You Raise Me Up, sounds like a spiritual song. Nobody knows the way I feel this morning. Only heaven knows, right? Okay. So these are great recommendations. Let's check out Black Girl. Let me see the recommendations we're gonna get from Black Girl. Gonna get Original Sin. Gonna get Bad Girl. I Did It All. It sounds like the sign of Black Panther. Looks like those jewelries that were used in Black Panther, so it makes sense. Yeah, the she go. Okay, let me go somewhere else again. Clean Up Man. Oh, sounds like a song that your mother sings to you. Show the top recommendations. So let me see. The Realist, The Body Rock, My Word, My Life, My Word. Still on it. Okay. I don't really see so much by intuition, but maybe the lyrics have some lot of correlation, which is why it is giving us this recommendation. So you see that we have our system working very fine. So yep. So the next I'm going to show you how to do is how to push this to GitHub. So just go to GitHub, then when you come to GitHub, next thing you do, you create a new repository, then you can just say music application recommendation smart. Alright, so you can create a license. I usually like using the MIT license, and then you can have the readme, and then you go ahead and create a repository. Alright, okay, so the next thing you do, you check out this code here. We're going to git clone it in my VS Code. So I can stop this application now. Control C. Alright, so what I usually advise, don't save your client and your secret your client ID and your client secret in the env file. So before you deploy, ensure you just uncomment this, comment this, and then you save, so that in case maybe somebody wants to use it, they can just impute their own unique client ID and secrets. After save, and in case maybe you want to reuse it again when maybe you're working with different system entirely, when you receive it back, you can just go and bring out your client ID and secret from your Spotify developer app and put it back there. So the next thing to do here is that I'm gonna create a git clone. What's called git init. Okay, let me first git init. Oh, I don't think when I do clone, I'm just gonna call it enough. Okay, so I come down here, git clone, copy that, then I'm gonna clone the arrow, I'm gonna clone the repo, and then we have it down here. It's under here. So what I'm just gonna do, I'm gonna copy the app.py over there, move, yep, then move the cache, move the .env also, window is empty. Then I don't want to move, I just want to move the test app.ipm, which is the Git notebook file, but I don't want to move this pkl, the similarity model, and this data set, because they are kind of heavy, and if you're moving this kind of heavy heavy files over if you're committing it over GitHub, it's usually problematic. So you might just leave that on your local file system. But definitely with that code and with the link to the Kaggle dataset, you can be able to create this artifacts of DF and similarity model. So you don't have to worry about that in case maybe you feel that maybe the users at the back end are unable to access that. By running that IPYNB file and the Kaggle dataset, you're able to create this .df.pkl and similarity model.pkl too. So the next thing you do is that you put git add, and then okay, I have to come to this folder. Right, I come open it in integrated, then git add. Alright, so git commit, call this first commit. So the first commit is just like the title of what we are doing, like this first commit. So commit means like you want to make changes into the Git repo online. So what do you want to call this? Editing, call it first commit, and then okay, then this has pushed this to like a temporary storage. That's what this git commit does. It pushes your proposed change to like temporary storage, and then to finally push this commit to the main branch where we have it at GitHub. We just put git push origin to main, then it does the magic, and then you have it there. So if you click command and follow this, you're gonna come back here, but if you load it again, you're gonna see that your files have arrived. But yeah, this is where you have it. Your test app.py, which is the implementation of the application using Jupyter Notebook. We have it here. So don't forget to like, share, and subscribe to my YouTube channel. Then I want to hear your feedback, your thoughts on this video. Especially my very first YouTube content, and I hope to spin out more content as time goes on. So yeah, thank you so much. Yep.